All right, we're on page 1 of the study guide, part 1, unit 2.3, similarity in similar triangles. Question 1, you're asked to find the measure of BD. And what's really important here is that we're told that BC is parallel to DE. So we know that when those lines are parallel, that those triangles ABC and ADE are going to be similar. We could prove that with angle-angle similarity, since we have two pairs of corresponding angles that are similar. And the first thing I would do here is label the diagram. Oops, as my lead breaks. AB is 9, AC is 15, CE is 25. I thought that was going to be the entire thing. And we are asked to find the length of BD. So we could either compare the entire small triangle to the entire large one, or we can use the side splitter theorem because those are parallel. So 9 over x, comparing the ratios of these two parts of the side, is going to be equal to 15 over 25. So you could reduce those fractions, or you could just cross multiply. 9 times 25 is 225, and that's equal to 15x. Divide both sides. We get that x is equal to 15. So the length of BD is 15 units. All right, number 2, you're asked to find the measure of PQ. Again, we have two sides. Sorry, my lead keeps breaking. I usually do this in pen. We have two sides that are parallel of these trapezoids, or assuming they're trapezoids, I should say. We're told that LP is 28, MN is 40, MO is 60. So if this whole thing is 60, we know NO must be 20, and then we're asked to find PQ. So again, we can use side splitter here because we're finding the sides of two similar shapes that are split by parallel lines. So we can do 28 over x or over 40, depends if you want to go left to right or up and down, and then 40 over 20. On one like this though, I could cross multiply. You're probably noticing that 40 is twice 20, so we know x has to be half of 28. So x equals 14. So PQ is 14 units. All right, number 3. This is another side splitter problem. Man, that must be an important theorem if there's 3 questions on our study guide. You're asked to find the values of x, y, and z. You are given the values of BD, DF, and FH, and you're told that from A to G is 133. So to get the ratio of like this length to this length, we're going to need to add these up, 20 plus 30 plus 45. So 20 plus 30 is 50, plus 45, it's giving 95 on bottom. So the ratio that we're going to compare these to, if I'm comparing top to bottom, is 133 over 95. All right, so I know that each length, so like from A to C, that value of x must be proportional to B to D, or these ratios should be proportional, I should say. All right, so when we cross multiply, we get 95x, and 133 times 20 is 2,660. So remember, when you cross multiply, your cross products are equal. Divide both sides by 95. And we get x is equal to 28. All right, so now I can continue to use this ratio of 133 to 95, or I could use the ratio of 28 to 20 if I wanted to have smaller numbers. It doesn't really matter because they should all be equal. So now when I'm finding y, I could do 133 over 30, or sorry, not over 30, over 95, because it's still the whole thing, is equal to y over 30. So that's going to be 95y equals 133 times 30, which is 3,990. When you divide both sides by 95, you should get that y is 42. All right, and then to find z, this last one, I'm going to use a different ratio. Oh, and I'm running out of room. Sorry, my work looks like your work sometimes. the ratio of z over 45, I could still set it equal to the ratio of the entire top to bottom or any part of the top to bottom. So since we already found x is 28, let's use 28 over 20. And now when we cross multiply, I get 20z is equal to 28 times 45, which is 1260. And when I divide both sides by 20, I get that z is equal to 63. All right, so that's our corollary to the side splitter theorem. We sometimes call that the egg slicer theorem when you have multiple parallel sides. All right, number 4, find the measure of x and y. We are given that triangle RST is similar to triangle VUT. And remember, in these similarity statements, that order is meaningful. So when R and V are in the same position, we know those angles are congruent. So right now, I'm just going to go ahead and label that this is 38 degrees for angle R, since angle V is 38 degrees. Then we know S and U are going to be congruent angles. S is represented by x degrees, so that's something we're going to want to find. And then lastly, we know T and T are going to be congruent, either because of their location in the similarity statement or because they are vertical angles, which you can just observe. So to find the measure of x, if we want to find that first, we're going to use that interior angles of a triangle add up to 180. So I could add 55 plus 38 and get 93 degrees and subtract that from 180. Oops, so 180 minus 55 plus 38. So 180 minus 93, we should get 87 degrees. So both angles U and S are 87. And that's our variable x we're solving for. And then to find y, we're going to have to use a proportion. So if you look at this problem, first of all, we're given that UV is represented with the expression 2 times the quantity y plus 5. I might go ahead and distribute that right now and say that's going to be the same as 2y plus 10. When I'm trying to think of what do I compare UV to, go back to the similarity statement and I'm going to need RS or SR. So I'm going to compare that to the number 7. So when I'm setting up my proportion, I'm going to use 2y plus 10 over 7. And I went from VUT to RST in that order. So now I need another side with known values, no variables to compare it to. And so if I look, I know that UT is 8 units and ST corresponds with UT. So I don't know what ST is, so that's not helpful. But I see that TV is 10 units and TV corresponds with RT because they're in the same position. So I could use the ratio of 10 to 4. The mistake people are going to make here is they're going to use 8 instead of 10 because they just want that scale factor to be 2 because that's a nice number. But we're going to use the ratio of 10 to 4 because those are the sides that are corresponding and we can tell that by that similarity statement. All right, so cross multiply, we get 70, and then we basically have to distribute that 4 to 2y plus 10. So I know that's going to be 8y plus 40 is equal to 70. I could subtract 40 from both sides. I get 30 equals 8y. Divide by 8. 30 divided by 8 is 3 3/4 or 3.75. So you should get the value 3.75 for y, assuming that I did not make a mistake. All right, the bottom of the page, this goes a little bit faster. For these questions, you're going to first determine if they're similar. If they are, you're going to write the similarity shortcut, so angle, angle, side, or side, side, and the similarity statement. So for example, triangle ABC is similar to triangle DEF. If they're not similar, you will write not similar. All right, so the first one, we are given no side lengths. So the only way they could possibly be similar is if there's angle, angle similarity. So they both have right angles. And then this one is labeled 64. So what I would do is 180 minus 90, which is just 90, minus 64, and figure out that this angle would have to be 26 degrees. And since it matches this angle, it turns out that they are in fact similar. The similarity shortcut is that they have angle-angle similarity. And then when we go to write the statement, it doesn't matter which way you spell, like which way you order the first triangle, but it matters that they correspond. So let's say that I did triangle WIG is similar to triangle. So when I said W, that was a 90-degree angle, so I need a 90 here. When I went to I, that was my 26 degrees, so I have to go to A. And then G was my 64 degrees, so I end on M. There we go. Number 6. No angles are marked, and they don't share any angles, so the only way they could be similar is through side-side-side similarity. Oops, sorry. I hit my camera as I was filming. So in number 6, you've got to look at the sides and match them up. I'm going to put an L by 72 for the longest and an S by 42 for the shortest on this triangle. And then on this one, let's see, 18 is the middle, the shortest is 14, the longest is 24. So when we match these up, we need to match long to long, middle to middle, short to short. All right, so from the one, the big triangle, we've got 72 is our longest side, and that corresponds with 24. And I might even just divide that and write what decimal I get. So 72 divided by 24 is 3. So that's a ratio of 3 to 1. So if I get the same ratio going around, I know they're similar. Then I'm going to do the middle sides. So 52 and 18. 52 divided by 18 is not 3. It's 2 and 8/9, or 2.8 repeating. So I can stop right there. Since that's not equal to 3, I don't even have to compare the shortest sides. I'm going to say that they are not similar. And since they're not similar, I'm neither writing the shortcut nor the statement because they would not be true. Last but not least, on this page, we have 2 pairs of sides for which we know the lengths. And I hope that by now, at the end of second semester, when you see vertical angles, they jump out at you. We've got vertical angles right here. So looking at the way that's labeled, if they're similar, I'm going to prove it by side angle side similarity. So I know the angles are already similar, so the A in side angle side is good. We got to check out the sides though. So I want to look at my biggest side on this one, which is 26, and my largest side on this one is 10. My smaller side is 13, my smaller side is 5. So the question is, does the ratio 26 to 10 equal 13 to 5? And another way of writing that, remember, we can switch our means or our extremes. So with the cross means product, I could rewrite this as 26 over 13, and is that equal to 10 over 5? It's easier to look at it this way because we know 26 over 13 and 10 over 5 are both equal to 2. So we know that they're equal. Our similarity shortcut is side angle side similarity, and the statement, again, you can name these however you want as long as you go in the right order. So let's see if we name the first one T-O-P. I crossed my longest side to that angle that they share and then cross my shortest known side. So if I do the same thing over here, I would start with D and not G. So triangle TOP is similar to triangle DOG. And you might notice that spells top dog because somebody thinks they're funny. All right, that's page 1.